Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the example number 3 for the Boolean function simplification using 4-variable K-map for the POS. So my dear students, in the last two lectures, we had discussed two examples regarding the 4-variable K-map solutions, and previously we had discussed 3-variable K-map solution for POS. And in the lecture number 83, we had discussed the different rules for POS K-map solution. Those rules include pair reduction, chord reduction, octet reduction, map rolling, overlapping, and redundant group reduction. So for detailing, kindly go through this lecture number 83. And my dear students, in this lecture we are discussing our third example. Our question is simplify the Boolean function using K-map pi of 3, 5, 7, 8, 10, 11, 12, and 13. So while analyzing the question, we can see that the set of max terms is less than 16. That is, we have to use 4-variable K-map or 4-variable representation. That is, this function can be written as f of a, b, c, d is equal to pi of 3, 5, 7, 8, 10, 11, 12, and 13. The 4-variable K-map consists of 16 cells with 4 rows and 4 columns, and the rows represents the variable a and b, and the column represents the variable c and d. So next what we have to do is consider the function. Our function is pi of 3, 5, 7, 8, 10, 11, 12, and 13. So what we have to do is mark the value 0 on this given cell positions. That is, we have to mark 0 on the cell number 3, 7, 5, 12, 13, 8, 10, and 11, and rest of the cell position should be marked with the value 1. So the given functions are marked in the K-map with the value 0, and the rest positions are marked with 1. And next what we have to do is identify the different pairs for this given K-map. So while analyzing this K-map, firstly we can see the first pair with the cells 3 and 7. So we are pairing the cells 3 and 7, and this pair is marked in blue color. Secondly, we can see another pair with the cell value 5 and 13, and this pair is marked with red color. And thirdly, we can see another pair with the cell values 8 and 12, and this pair is marked with the yellow color. And finally, the fourth pair is between the cells 11 and 10, and this pair is marked in green color. So here we got 4 different pairs, and next what we have to do is reduce these individual pairs. While analyzing the first pair, this pair lies in the third column and in the first and second row. In the first and second row, the value of a is 0 in both these rows, and the value of b is 0 in the first row and 1 in the second row. So we have to consider only the variable which is unchanged or remain constant. Here b is changing its value, thus b can be ignored, and we can take only the value of a, which is a is equal to 0, and since it lies in the third column, the value of c and d is constant with c is equal to 1 and d is equal to 1. Therefore, the reduction of the first pair will be a plus c bar plus d bar. While analyzing the second pair lies in the column number 2, and it is between the row 2 and the row 3. In the row 2 and 3, the value of a is 0 and 1, and the value of b is 1 in both these rows. Thus, we have to consider only the value which remains constant. Thus, we are ignoring the value of a and considering the value of b only. Therefore, b is equal to 1 is taken to the final reduction, and since it lies in the second column, the value of c and d is 0 and 1 respectively. Therefore, the reduction for the second pair is b complement plus c plus d complement. While analyzing the third pair is in the first column, and it is in the third and fourth row. The value of a is equal to 1 in both these rows, and the value of b is changing from 1 to 0 in this set of row. and the value of C and D remains constant with C is equal to 0 and D is equal to 0 since it lies in the first column. Therefore, the reduction for the third pair is A complement plus C plus D. And finally, the fourth pair lies in the fourth row and in the third and fourth column. Therefore, for the reduction, the value of A and B remains constant, and while analyzing the column values, the C remains constant and the D value is changing from 1 to 0. Thus, the final reduction for the fourth pair is A complement plus B plus C complement. Thus, we had reduced all the independent pairs or groups, and the final POS for this given function will be ANDing of all these individual pairs. That is, POS is equal to A plus C complement plus D complement into B complement plus C plus D complement into A complement plus C plus D into A complement plus B plus C complement. So the given function can be reduced or represented in POS like this. So my dear students, hope you had understood this topic. So dear students, our assignment question is simplify the Boolean function using 4-variable K-map, and the function is f of w, x, y, z is equal to pi of 0, 1, 5, 7, 10 and 11. So my dear students, in the upcoming lecture, we will discuss how to represent a logical circuit diagram for a POS representation. So my dear students, see you soon. Until then, goodbye, thank you and all the best.